You have probably watched a hummingbird at a feeder and thought you understood what you were seeing. A small bird, fast wings, drinking sugar water, moving on. You were wrong. Not about what you saw, but about what it means. Because what is actually happening inside that bird, in its chest, in its muscles, in its brain, at the moment it hovers in front of your feeder, is so extreme, so physiologically improbable, so far outside the boundaries of what we expect a living creature to be capable of, that if you understood it fully, you would not be able to look away. Welcome to Wild Bird Life Mind. Subscribe before you leave because what you are about to learn will permanently change the way you look at the smallest bird in your yard. Today we are going deep into the hummingbird. Not the surface version, the real version, the metabolic impossible, the navigational miracle, the creature that should not exist by any reasonable reading of the rules of biology, and yet does, and does so with a kind of furious perfection that has no parallel in the bird world. Let's start with the heart, because everything about the hummingbird begins and ends there. A human heart beats roughly 60 to 100 times per minute at rest. A dog's heart beats around 70 to 120 times per minute. A hummingbird's heart, at rest, beats between 250 and 500 times per minute depending on the species. During active flight, that number climbs. Researchers measuring heart rates in ruby-throated hummingbirds during hovering flight have recorded rates exceeding 1,200 beats per minute. 1,200 beats per minute. That is 20 beats every single second. That is a heart that never stops hammering, never pauses, never slows to anything a human cardiologist would recognize as a resting state. At least not during the day. The reason for this is the wings. A ruby-throated hummingbird beats its wings approximately 53 times per second during normal forward flight. During courtship displays, that number climbs higher. The energy cost of this is extraordinary. Hummingbirds have the highest metabolism of any warm-blooded animal on Earth, relative to body size. A hummingbird operating at full capacity burns through calories at a rate that, scaled to human body weight, would require a person to consume roughly 300 hamburgers per day just to maintain basic body function. This is not a metaphor. This is the actual metabolic math. And it creates a problem that the hummingbird solves in a way that should stop you completely. The problem is nighttime. During the day, a hummingbird manages its extraordinary energy demands by feeding constantly. It visits between 1,000 and 2,000 flowers per day. It drinks its own body weight in nectar daily. It supplements that nectar with protein from small insects and spiders, which it catches in flight or plucks from spiderwebs. Every waking hour of a hummingbird's life is organized around fueling a metabolism that runs so hot it would destroy most other animals. But at night, there are no flowers. There is no nectar, and a hummingbird cannot maintain its daytime metabolic rate through 8 hours of darkness without feeding. If it tried, it would burn through all its energy reserves within 2 to 3 hours and die before midnight. So the hummingbird does something that, when researchers first documented it fully, seemed almost too strange to be true. It shuts itself down. Every night, or on cold days when food is unavailable, hummingbirds enter a state called torpor. Torpor is not sleep. Sleep is a resting state where metabolism is modestly reduced and the animal remains capable of waking quickly. Torpor is something far more dramatic. In torpor, a hummingbird's heart rate drops from 1,200 beats per minute to as low as 50 beats per minute. Its body temperature, normally around 104 degrees Fahrenheit, plummets to within a few degrees of the surrounding air temperature. Its breathing slows to near imperceptibility. Its muscles become unresponsive. A hummingbird in deep torpor will not react if you touch it. If you pick it up, it will hang limply in your hand. For all practical purposes, it looks dead. People have found hummingbirds in torpor on cold nights and called wildlife rehabilitators, convinced the bird was dying. The bird was not dying. The bird was doing the most sophisticated energy management trick in the vertebrate world. It was temporarily turning off. The cost savings are extraordinary. A hummingbird in torpor uses roughly 50 times less energy than a hummingbird in normal resting sleep. By entering torpor, the bird extends its fuel reserves from a few hours to an entire night. When dawn comes, the bird's body temperature begins to rise. Its heart rate climbs. Its muscles warm. Within 20 to 60 minutes, the hummingbird goes from something that looks indistinguishable from death to a fully active animal vibrating with energy and feeding at a flower. Every morning, for every hummingbird that survived the night, is a resurrection. Now let's talk about the wings, because the wing mechanics of a hummingbird are so different from every other bird that calling them by the same word, wings, is almost misleading. Every other bird on Earth generates lift primarily on the downstroke. The upstroke is mostly a recovery stroke, a repositioning of the wing for the next downstroke. It generates some lift but not much. The mechanics are similar to how a swimmer's arms work. One direction does the work. The other direction resets. Hummingbirds generate lift on both the downstroke and the upstroke. They achieve this by rotating their wings almost completely at the shoulder joint on the upstroke, essentially flipping the wings so that the same surfaces that push air down during the downstroke now push air down again during the upstroke, just in the opposite direction. The wing traces a figure-8 pattern in the air, generating thrust on every phase of the stroke. This is why hummingbirds can hover. This is why they can fly backward. The only bird in the world that can do this is a normal part of flight. This is why they can fly sideways, upward, downward, and can stop in reverse direction in a fraction of a second. Their wings are not modified versions of the same tool every other bird uses. They are something genuinely different, a redesign so fundamental that the hummingbird is in some sense not doing what other birds do when it flies. It is doing something else entirely that happens to also be called flying. The shoulder joint that allows this rotation is proportionally the largest and most complex shoulder joint of any bird. The hummingbird's pectoral muscles, the muscles that power the wings, account for roughly 25 to 30% of its total body weight. For comparison, a strong flying bird like a pigeon has pectoral muscles representing about 15% of its body weight. The hummingbird is, by design, mostly engine. Now let's talk about migration, because this is where the hummingbird story becomes something that is difficult to fully process even when you understand the numbers. The ruby-throated hummingbird, the species most likely at your feeder if you live in the eastern half of North America, weighs approximately 3 grams. That is less than a US penny. It breeds across the eastern United States and Canada and winters in Central America, from southern Mexico to Panama. To get there from its breeding grounds, it must cross the Gulf of Mexico. The Gulf of Mexico is approximately 500 miles across at its narrowest point. A hummingbird crossing the Gulf of Mexico non-stop, which they do, is flying 500 miles over open water with no place to land, no place to feed, no shelter from weather, on a body that weighs less than a penny and burns through fuel at a rate that would be catastrophic if not for the extraordinary preparation that precedes the crossing. In the weeks before migration, ruby-throated hummingbirds enter a phase of hyperphagia, a period of compulsive feeding where they consume as much nectar and insects as possible. They can double their body weight during this period, storing fat reserves that will fuel the crossing. A bird that weighed 3 grams may weigh 6 grams before departure. Those 3 extra grams of fat are the fuel for a 500-mile non-stop transoceanic flight. Researchers studying hummingbird migration have calculated that the ruby-throated hummingbird arrives on the other side of the Gulf with almost no fuel reserves remaining. The crossing consumes nearly everything. A bird that delays its departure into bad weather, or encounters unexpected headwinds, may not make it. There is no margin. There is no safety reserve. The bird either makes it, or it doesn't. The ones at your feeder made it. Every single one of them. Every ruby-throated hummingbird you have ever seen in the eastern United States crossed the Gulf of Mexico and survived. It crossed on a body the weight of a coin, carrying exactly enough fuel and no more. Now let's talk about memory, because the hummingbird's navigation and spatial memory are as extraordinary as its physical capabilities. Hummingbirds remember every flower in their territory. Not approximately, not generally, specifically. Research on hummingbird foraging behavior, particularly studies done on rufous hummingbirds by researchers tracking individual birds, has shown that hummingbirds maintain precise cognitive maps of every nectar source in their territory, including how long ago they visited each flower and approximately how much time that particular flower species takes to refill with nectar. A hummingbird that visits a flower and drains it does not revisit that flower immediately. It moves to other flowers in its circuit and returns to the first flower at approximately the interval required for it to have refilled. It is tracking time. It is running a schedule. In its tiny brain, which weighs less than a single raisin, a hummingbird is maintaining a spatial and temporal database of every flower in an area that can span several acres. The part of the hummingbird brain responsible for spatial memory, the hippocampus, is proportionally larger than the hippocampus of most other birds. The brain has literally grown to accommodate the demands of remembering an entire landscape at the level of individual flowers. And the migration navigation adds another layer. Hummingbirds return to the same wintering grounds, the same summering territories, often the same individual yards, year after year. They are not finding their way generally. They are finding their way specifically, navigating to places they have been before with precision that would challenge our best GPS systems. A hummingbird that spent last summer at your feeder may be on its way back right now, crossing the same gulf it crossed last fall, heading for your yard, your feeder, the specific perch on the specific branch where it rested between visits last July. Here's what all of this should leave you with. The next time a hummingbird appears at your feeder, what you are looking at is an animal whose heart is beating 20 times per second, whose wings are moving 50 times per second, whose brain is running a precise map of every flower in the neighborhood with refill timing attached, whose body recently spent a night in a state indistinguishable from death and woke up, whose ancestors crossed 500 miles of open ocean on the fuel equivalent of 3 grams of fat, and who found your yard, specifically, perhaps because it found your yard before and remembered it. There is no bird quite like this. There is no other animal quite like this. The hummingbird is not a small version of something larger. It is a completely different solution to the problem of being alive, one that runs hotter, faster, closer to the edge, and with less margin for error than almost anything else with a heartbeat. The fact that it keeps showing up at your feeder, calm and precise and apparently unbothered by any of this, is either the most impressive thing you have ever witnessed, or proof that the hummingbird has no idea how extraordinary it is. Either way, you do now. Tell me in the comments, do you have hummingbirds in your yard? When did they arrive this year? Have you noticed one that comes back to the same spot? I read every single comment. Subscribe to Wild Bird Life Mind for more on the birds outside your window and what they are actually doing out there. I will see you in the next one.